Today we are going to be tackling data types. So generally when you write a program, you do some operations and you also manipulate data. For instance, consider a program like a ticketing selling program. So the ticketing selling program needs to keep track of how many tickets are left. So it needs to manipulate some data. It needs to store that value in somewhere. So that's basically what data means in programming. But for every type of data you store, you must know the type. For instance, a person's name is like a sequence of characters, so it's like a string. In Java, it's called a string. Someone's age is like a number, so it's an integer. So Java is strongly typed, which means if you want to create something called a variable, you need to specify its type. So let's say I want to keep track of how many cars someone has. I can store that in something called an integer because it's numeric and it's also whole numbers. Even though it will make sense to have negative number of cars, an integer can store negative numbers. So an integer can store negative and positive numbers. Now it can only store up to around 200 billion because it's fixed to 32 bits. So to create an integer, all we do is we type the word int and the name of the variable. So what we've done here is we have declared the integer. The integer here does not have a value yet, but we have introduced the name to the program, so we can go ahead and give it a value. To give it a value, all we need to do is we just put an equal to sign here, and let's say we put 4 there. So that means A is storing the value 4. So if I print out A, we should see 4 printed out because A is storing the value 4. Now A can later go ahead and change what is being stored there. So A can now store 90. So if I print this, we'll see 90. Sorry, I missed the semicolon. In Java, you need semicolons at the end of your statement. So if I print this, we see 90. So now this is the first data type. It's called the integer. To create an integer, you just use the keyword int. You can also store negative numbers. It's not a problem. But there's also a limit to that, around negative 2 billion also. So we can store from 0 to positive 2 billion or something, and negative 2 billion. That's for integer. So you can store things like number of cars, number of houses. You can't possibly store the number of people in the world because that's more than 2 billion. For that, we need the new type I'm going to introduce, which is called the long, L-O-N-G. So this type stores larger numbers up to 9 times 10 raised to the power 18. So those are very huge numbers. You can easily store the number of people in the world in this variable. Now to create a value that is going to store, to create a, you see here we are initializing it to some value. If it's a long, what you need to do is you need to suffix end it with an L. It can be a small L or a big L, but it's better to use a big L because it's more readable. So this is a long. So when you print this out, it's also going to be printed like a regular number. Nothing special, nothing that indicates that it's a long. But here we can store bigger numbers. For instance, I can store the number 9 billion. So let's store 9 billion and see 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I run this, it works. But if I change this to an int and I run this, you see the IntelliJ is complaining. It's saying that the required type is an int and wants to a long. So even if I remove this L, you will see what happens when I run this. Oh, how come it's being stored? What number is this? 0, 0. These are 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we need another 0. Yeah. So now this won't work because it says the integer number too large. But if we specify a long here, and we make this capital L, this will work. Now notice that if you miss the capital L, you have a bug because it won't compile, because when Java sees a literal number like this, it assumes it's an integer. So this is for the long type. Now we have other numeric types, whole number types, called the short. This is for way smaller numbers. It stores up to 16 bits, so around 60, around 30, I think 32,000, about a little above 32,000. So we can store, let's say, 32,000 here. So if you print this, we have, but if we were to store another number here, you see we have the red line because it's too big for the type short. So you don't typically use shorts. You typically use int and long. But for low level applications, you may have to use short if you are pressing on memory. So for instance, you are storing a large number of numbers and you know the numbers are small, you can store them in a short. There's even a smaller type called the byte. Now this can store numbers up to 127, because this is a byte is 8 bits. So this is the biggest you can store in 8 bits because it's also signed. So some of the part of the number is negative. Some part you can store negative numbers as well. So if we print this too, you see the value 127. So now these are the integral numeric types. Now we also have the floating point values. So if I type float and I do x equal to 90, now these values can store decimal numbers. So for instance, the area of something or the radius of something, anything that ends with a 0.0 or 0.2. So if I have 90.5, I can store it in a float. So to specify a float, you need to use capital F. Yes. So this is x. If I print x, I have 90.5. Now note that I can't store this in an int. See, we have the red line here because this is a floating point value. So you can only accept integral types, so whole numbers. So that's what the float is used for. But typically, we don't use the float. We normally use what's called a double because it's more precise. The float can store up to 7 decimal places, but this can go up to 15 and even more. So we can store floating point values like this. For the double, we don't need to specify anything because when you write a literal value like this with a point, it assumes it's a double. So here, if we print out this, we have 45.5 printed out. Yes, it's also printing this one. Okay. Now let me introduce something I didn't speak about is the commenting. So when you're programming, sometimes you want to make some note of something you've done. That's when you use commenting. What you do is you just do control / or 2 / and type whatever you want. Now this is not going to be run. It's going to be ignored by the compiler. So that's something to note. That's called commenting. Okay, so these are the numeric types. Now we have some more types. There's one more type. There are two more types that we have. One is the char type. Now this stores individual characters. So I can store the character D. Remember, I'm using single quotes. It needs to be in single quotes because if you use double quotes, that's a string. So here I'm using I'm storing D. So if I print out this, let's see something interesting that happens. It prints D. Now each character, the char type can only store a single character. So I can't do this. This won't work. I can only store a single character. So that's for character. We'll get to understand how the character type works. It is an interesting type because every character needs to be presented by an integer. And in Java, we use UTF-16. This means that the character is encoded in 16 bits. But with 16 bits, there are some characters that you cannot encode. So what Java does is it uses 2 characters to represent a single character, like a single character in a string. For instance, there's a character that to be able to represent it, you need 2 characters, and those 2 characters that are used are characters that are not typically in the 16-bit range. So we'll get to that later when we get to strings. We'll explain that later when we get to strings. So that's for char. Now there's also the boolean type. Now this stores something called true or false. Now true just represents the truthiness of a statement. So for instance, I can say I will go to school tomorrow. If I'm actually going to school tomorrow, that statement is true. So true just indicates that it's the state of a condition. You can also store false. So remember, these are not strings. They're not in quotes or they're not chairs. They're also not numbers. So these are the all these types 1, 2, 3, 4, 5, 6, 7, 8 are the primitive types. They are called primitive because they are basic. And in Java, in memory, the value you see there is the value that's going to be stored in the variable. Later on, we'll talk about reference types and you see it's stored a bit differently. So these are the primitive types you have in Java. Thank you.